this is nothing going to be. It's not going to be too formal. This is just going to be showing you the templates that you can play with within the protocol, and how you might get started building on top. So the video is going to be on YouTube. So I wouldn't stress too much about missing some details, and you'll be able to watch it back retrospectively. Without further ado, I'll just get back into it. So I'm going to do it from the perspective of somebody coming new to the site. So just I feel like I should be singing a song here, right? Yes, the whole day will be recorded. So if you missed any sessions throughout the day, maybe you didn't see the talk at 9 o'clock, you'll be able to watch it all back. So yeah, absolutely. So best behavior, really. Right. So if we, right, I might have to hold this. Okay, so Academy, right? So this is what you should be taken to. You'll see this cool Lego app, right? So right, okay. So you'll be taken to the Stakehouse Academy. In terms of the templates, you've got the descriptions that I previously mentioned, and you can go to our GitHub repo. So we got the templates. We hope to continue to expand this. The focus here is DETH and the SaveEth registry. We'll be looking at MEV and all the other things that people were asking about later on. But let's, like I said, let's do this from the perspective of somebody coming new to the site. So you'd come to the templates. As I showed you at on the previous talk, the smart contracts are live on Gorelli, so you can get building straight away. We have a subgraph where you can fetch all the information you want about the validators registered in the protocol. We've got hundreds registered, and people registering all the time. We have a community faucet that gets topped up from time to time with Gorelli ETH, which is hard to get hold of. We are going to give it to some people today who want to get involved and set up a validator in 60 seconds or 2 minutes, depending on if you're running the node as well. So in terms of getting stuck in, because you need to get your hands on the Gorelli ETH to stake it, to then obviously interact with the protocol. But the data's all there. This is just repackaged data from the smart contracts that anybody can index. You can get all the data from the beacon chain and calculate yields available from every validator on the network. So that is referenced in the in the templates. So we've got here the subgraph that you can access, and some example smart contracts that you can get hold of. But there is the schema here. You can read all the data about. You've got global values like the smart contracts you want to interact with. In terms of the templates that we have here now, we've just got the main ones that you're going to want to interact with currently with the templates. It's to do with the yield side, the passive yield. And so that means the SaveEth registry or the transaction router, which is just for registering your validator. So that's for like interacting with the Ethereum deposit contract, and sending your ETH, but registering the deposits so that you can get your derivative tokens. Somebody asked a really interesting question during the pizza segment, and the question was just, how can you claim the underlying ETH when Ethereum Foundation enables withdrawals? How can you claim the underlying ETH? And the answer for me is quite simple. The fact that when a validator is registered and the 32 ETH deposit is made, the fact that deposit is tracked in the registry. The BLS public key, all sorts of information about who did the deposit. That allows you to mint your derivatives once the beacon chain has completed all of its checks. From the eligibility point onwards, you can mint your derivatives. From the activation point onwards, you will be earning yield. You can mint your derivatives. Now, when you want to burn the tokens, because there is a registry of what validator did what deposit when, as long as you hold the derivative tokens, you can take the tokens out of supply, burn the tokens, and claw back the underlying ETH. You just ask smart contract, hey, I burnt my tokens. Give me my ETH, and I prove to you that I've done it. And that's one of the biggest things we focused on in the audits is issuance and redemption. Making sure that you get the correct amount of derivatives issued, your deposit is tracked correctly, and that you can redeem your tokens, right? This is how we can say you have ownership of your assets, the underlying ETH. If you cannot burn your tokens and get your underlying ETH, you don't own the underlying asset. With that in mind, so what we'll do is we'll go to the templates, and what I'll do is I'll just clone. I'm going to try the stand again. All right. Try and get two hands. So what I'll do is I'll just I'll do this as somebody brand new to the system. You imagine you're coming to the academy for the first time. So we'll clone the templates, install the dependencies. It's just in there. It's just smart contracts. You got it's set up with hard hat deployment scripts. You can use whatever you want. Foundry, the contracts are there. So if you know how to use other development frameworks, that's down to you. We're just giving you an out the box examples. All right. So Stakehouse Temp. Right. So we'll yarn it up. There's nothing crazy in here. It's just you got some examples for the Open Zeppelin is just if you want to for example, earlier I was giving the example of how you have this index, for example. It has 4 knots in the index, each earning its own yield. The index has an aggregate yield from that, and you can fractionalize it with an ERC20 token. So, there's so many standard templates for ERC20s. You just go to Open Zeppelin. You don't have to build it yourself, and you're away. The GraphQL request shows you how to query the data from the subgraph, how you can do all your calculations. Because I said in the previous session that one of the cool things about the yield is you can see the yield happening alive without poking the smart contracts constantly. So you've got, you know that you are the owner of, let's say you're the owner of this index. It's got the single address owner, and you can just query the balance, and you can watch it going up. You don't have to ask the smart contract, well, how many tokens do I have? It's not like a yield farming situation. You've got publicly verifiable data that tells you exactly what it is, so you can have it on a dashboard. However you want to do it. But if you want to mint the tokens, that's, you can claim that whenever you want. Right. So we've cloned the templates. So what I'll do is I'll just spin up a project. We'll trust it. Right. So okay, we're all good. So right. Okay. So you've got all these. Like I say, you've got the example of how to fractionalize this. So this smart contract is for example, it's just the ERC20. It owns an index. So in the case of this index here. You can query all the indexes, obviously, but in the case of specific index number 3, it has all these knots. So this is where in the smart contract you would track what index the contract owns. But in this case, when the contract gets deployed, the contract is actually creating an index here, and it's specifying itself as the owner. You can have people creating indexes on behalf of yourself if you wanted to, but then that address owns the actual all the knots in the index. And like I said in the previous session, you can have tradable indexes. So you can sell the whole index with all 4 knots in it. You can trade the specific validator. You can package it in whichever way you want to do it. And this simply just mints 5 million tokens to 18 decimal places. But what I wanted to do is just so we have this concept of representatives. So representatives can do staking on behalf for you. You can approve somebody to say, oh look, I have the Ether, but I don't care about staking. I don't care about all the complexities of how to do it. I just want you to give me derivatives. So you can approve somebody and you can say, well, here, you are my appointed representative. You can facilitate the transactions that do the staking, but as an appointed representative, they never get the tokens. So you can receive the tokens, that's fine, and have somebody else clicking the buttons, paying the gas. You've got that sort of thing. So so with the Moloch example that we showed earlier, so on the Academy docs, so we have this this example of how to do like putting the DAO treasury to work. You have your ETH and you have an appointed representative. How are they going to put that ETH to work and give the DAO the derivatives? There's no point in having a representative if they can walk away with the derivatives. But here you can appoint somebody, but you keep the token. So this is where we had the example of like you have these people that these people pooled some money together. You have the 8 ETH, the 6 ETH, the 12, and then the NFT. All these NFTs essentially form a multi-sig that owns the DETH, the SAR, all that sort of thing. So that's where you can see. So here in the actual template code, you can see how you can replicate that yourself. So you can deposit. You can deploy the contract. You can sacrifice ETH, and then you can go through the process of. You can see we're going to put out some infographics and explain how the deposits flow works. It's not. There are a few steps to complete for security reasons, but once your validator has been approved by the beacon chain, you can have your derivatives. But there is a flow involved, and that tries to guide you through that. You can batch stake as well. You can do multiple at once. But I think what's interesting that we wanted to show and talk about was this this yield protocol. So the idea is that you might out of the box, what's deployable here is offering people an ETH savings account for their DETH. So you as a DETH holder who doesn't know anything about Stakehouse protocol, you can put your DETH to work. So that that you deposit funds into a protocol contract, this yield protocol contract, and you lock it up for a year. And you come back in a year time and you get your original principal amount plus the interest. And this protocol actually gives you a receipt token representing your deposit that you then burn later on when you come back and claim the original amount plus the new DETH. But you can create all sorts of strategies around this with the LP token that you get. You can deposit it for more ETH, and and I mean you can do whatever you want with it. But one of the interesting things is, so this can be modified to build a self-repaying loan. So in the context of money markets and building various money markets, you have out-the-box support for, not out-the-box. So using the programmable primitives that are offered by the Stakehouse protocol, you can build things like a self-repaying loan. So the idea is that you have DETH and you want to borrow potentially USDC against that. Your DETH is worth an amount. You can do this however way you want, but like Chainlink, for example, they give free oracles for the ETH USD price, so a protocol can easily go and fetch the price on chain. It's updated all the time. It's because it's one of the most highly traded assets in the world. You might not necessarily get a free price feed for a smaller token, but they give you a free one for ETH USDC for example. So you can say, well, somebody can come in and say, I want to borrow 1,000 USDC against my DETH. And whilst you have gone off, so you've deposited your DETH into the protocol, whilst you've gone off with your USDC, the fact that the DETH is earning inflation rewards from the beacon chain means that the collateralization ratio is improving all the time. So the loan is repaying itself because the interest is accruing on the beacon chain and can be reported as DETH. So your DETH is going up and up and up and up, and over time, if you wait long enough, you have your loan paid off. So how would you do that, for example? So in this protocol, for example, you have a deposit function. So this is I'm going to try and 1 second. I'll just switch this to presentation mode. So view appearance. I need a shortcut for this. Right. Okay, that's better. So right. You have the ability to borrow. This is a deposit function. So you simply have DETH. You're a user. You have DETH, and you wanna borrow some USDC. So you're depositing ETH as somebody who's approved the contract. The contract has some internal accounting about how much DETH it has, and it mints back a token. Now this is the ETH savings account. This can be changed to instead. This could be, instead it could be like transferring USDC, right? So you can say based on the address of USDC token. Right, you can transfer. Let's say this contract. Let's assume the contract owns the USDC and is giving it out in exchange for DETH deposits. So here it's minting 1 for 1, but you might have some calculation for you'll have so you'll have some USDC amount owed, right? So you do some calculation here. Right, so something tells the smart contract that based on the amount of DETH being deposited, how much they can claim, or the user is specifying, because maybe they want to specify like they only want to draw small amounts against their DETH so that there's no liquidations or there's no issues, right? It doesn't really matter. Something tells the smart contract how much USDC is allowed to be relinquished, and then the user is given that. So the contract is just accepting this DETH, but it needs to put the DETH to work in the index. The SafeETH registry is the link between DETH and the yield on the beacon chain. It's where the reconciliation of the accounting is happening between the two chains. And we saw Everett from Runtime Verification talking about the invariant that they checked, which ensures that the ETH on the execution chain is backed by the correct amount of ETH on the beacon chain. So we have these properties checked, and anyone can verify them. So it's a registry-based system. You can query any validators registered with the protocol, and you can see exactly how much they're earning. So different loans will pay off at different rates. A validator that is being run with 100% efficiency, like squeezing all the juice out of the beacon chain, will pay off a loan much quicker than a validator that's online, maybe 85% of the time. You can see, and you could even like price your loans accordingly based on the performance of the validator. Oh, you're going to take much more longer. You're going to take longer to pay this loan. Your fee for taking out this loan is higher, and it's you can calculate this data easily on the fly. But so long as the beacon chain continues to issue ETH inflation rewards, this loan has got the ability to pay back. So the user never has to come back to the smart contract. For the loan ever to be repaid. If they want to claim it at some point, they will do down the line. But the protocol is never in like a situation where maybe the payments aren't being made. So the idea is that potentially you could be in a situation where you borrow some USDC, it gets paid off by itself, and you claim your original DEs back. You wouldn't get the original interest because that's been paying your loan, but you can come back and claim your original DEs. You still have the USDC. You've just converted your DETH to a US dollar of account. So these are just like example templates. They're not been audited. We're just putting out use cases to people. We will verify them with some tools that we have internally. We're going to talk about the Satora tool very shortly. Muli's going to come up and introduce it, and then we'll expand on his talk about how we're trying to incorporate this tool as part of our development. So it's one of those things that it's just like an example, and you can modify it and use it in whichever way you want. So you have some type of burning mechanism, but then you have like the strategy. So there are the DETH that you've accepted into the smart contract is it can be managed by a DAO or whatever. So you're either going to put the DETH to work in the SafeETH registry and you're going to get the yield from the beacon chain, or you're going to remarket the DETH via some other strategy. You're going to lend it to another protocol that's going to give you more yield, and maybe you're going to make a difference between the beacon chain yield and and the protocol, what the protocol is making elsewhere by doing X, Y, Z strategy, and then the protocol makes some profit that way. I mean, the point here is that there is many ways to skin the cat. What this is trying to show you here is that you have is the integration points. So where do you start? What do you do with a DETH? You know, you're a protocol. You've taken DETH. What do you do with it?
Another scenario is like if we have a DETH,
Uh-huh.
an index.
Mm-hmm.
If you put an element finance or your own finance, right? They have a standard rate.
You want to come up?
No,
Or just so people can for the recording.
I can hear you.
No, for the recording. Oh, okay.
So element finance or your own finance, they have standard rate, right?
Uh-huh.
Most of the ETH is like 1% or 2%. It's not really like paying off great.
Yeah.
But if you have a DETH, an average of 5.6%
Yeah.
today, because it's 25% more,
Yeah.
or 4.7 is the average rate, you get more, like if you give the index, if you get a share of an index. So in this case, the DETH is in part, it's being curated by any of these aggregators, right?
Yeah.
Let's say Idle, Earn, or Element. Is a user can get additional yield on top of what they're getting from this 5%.
So the question is, can the user get more than the right? Okay, yeah. So the beacon chain will only give you X percentage, and that's based on the number of validators that are registered with the network. But somebody who deposits DETH into Yearn Finance or Element Finance will get a shared token back, like in this case we've got like a YV DETH. You would get that LP token back, and that LP token has a value, right? Because it can be burned for future DETH inflation rewards accrued. So you have various strategies where you can get into leveraging, and you can remarket that LP token because the LP token has a value. But all along the way, it's all traced back to a single source, and the source is the validator. The initial 32 ETH is the seed that grows. And it's all traced back, and it's verifiable at any different level. So if you're getting a third, fourth order, sixth order derivative, you should be able to, as long as they're exposing the right data, the beacon chain is and the Stakehouse protocol is, you should be able to trace back that yield down to the source of where it's coming from. And that's the power of publicly verifiable data. You don't have to trust a protocol that says to you, hey, I'm going to give you 10%, I'm going to give you 10% yield. Okay, well, that's cool. Like, you can take that at face value, or you can go and verify it yourself, right? And you can run your own node to do this, right? You can say, oh, well, your yield is coming from X, Y, and Z validators, and I did my own calculations. You said 10%, it's actually 9.8, but, okay, it was close. Or you're lying, it's only 6%, right? So the point is you don't have to trust, you can verify. And that's the key philosophy throughout the whole design and building of the Stakehouse protocol, is like everything needs to be publicly verifiable, and it's the same with slashing, right? If you're not managing your validator well, you're gonna lose your balance, right? Everybody can see it. Everybody wants slot because the slot represents a block production, right? So if you don't manage it well, somebody will take it and manage it better.
So in this manner, like in the traditional finance, you have this auto and on bonds from the Fed, right? Yeah.
The US Fed, yeah.
Right? Yeah. So you have the same bond is issued by the singularity, but it has a different yield. Yeah. And if you want to get an average, there's a CMT curve as you go and get that yield curve, right? Normally. But here, what you're saying is like some of the validators are really good, they're paying off really well. Yeah. I want to have those yields. I want to get that. Is there a smart contract or protocol simply curating BLS keys of that validator from the Stakehouse, and they are giving you this kind of a high grade, DETH? Would that be possible to get an extra scoring or things like that automatically?
Yeah. So how do you curate validators that are, or how do you arrange validators that are performing differently? And that's where the SaveEth index comes in. So you have protocols that can curate these indexes. So you just create an index that has an owner, and you can add any number of validators in there, and you can curate, as Matt said, you can do high performing validators. So you have this index that has the super efficient validators. They have the best node infrastructure, or whatever the reason is that they're super performers. and you can remarket maybe a fraction of that at a higher premium than maybe validators that are only online 60% of the time. You can separate that, and you can give people a slice of the pie. Maybe you can't afford the higher yielding ones, but maybe you still want to put your ETH to work and get some exposure. The index will allow you to segregate and have subgroups of validators earning different amounts, but you have this aggregate yield that you can expose in any which way you want. You can put a CMT curve. You want to think of Matt was talking about the Federal Reserve and the Treasury in the US. There's a lot of different analogies between the Stakehouse protocol and the US Treasury that issues these bonds. Like, if you want to lock up your money for 10 years, you're going to get a better rate than if you lock up your money for a smaller amount of time.
So you're literally telling, you can tell Grayscale.
Hey, Grayscale, get rid of, what's the ETH?
Yeah, ETH index, and say that we don't trust your premium. We can just allow the smart contract to do this curation, take out some of the validators from time to time, looking at it, and it will automatically curate it, and the premium and the discount will be based on that, how it is working.
And we want to show by any smart contract can curate the validators in an index and expose it to whoever they want. And the way that we built this thing with simplicity in mind is that we want anybody, no matter where you are, no matter your skill set, to, in a matter of minutes, spin up an index, add validators to that. And when you bring the barrier to entry so low, it makes things very interesting. But it just means that anybody can do this. Anybody can spin up a money market. If you wanted to try and hack at that, on the weekends, you got the hackathon. Anybody should be able to do that, right? We tried to test it internally, but we want to remove our bias by exposing these templates and saying, well, you go ahead and you try it and see how difficult it is. Maybe we need to add some documentation, but like, if anybody can spin up these indexes, add validators into them, and expose the yield from that, then we've got like a game changer for a brand new financial substrate to underpin the whole of DeFi. And remember, this yield is sustainable so long as the beacon chain is around. There's no lending and borrowing, and you have a rate based on supply and demand. You have the beacon chain that is issuing this fixed income yield. And that is the basis for building sustainable protocols on top of that for the whole of DeFi. So this is what we mean when we say, let's build, where's the presentation? This is what we mean when we say, let's build the next generation of unstoppable money markets. So the protocols are mutable, the income is fixed, right? You can build a sustainable protocol on top of that. Or, you can benefit from other people building on it and buying a share of whatever, token that they issue. But everything's traceable back to a seed, which is a 32 ETH. It's a batch. Every validator's 32. Everything's traceable back, and you don't have to trust. You can verify.